Welcome to Context Window, your weekly look at the bleeding edge of AI coding tools. Let's see what's new.
There's a growing argument in the AI world that paying top dollar for the most advanced, frontier models might actually be a suboptimal financial decision for many real-world applications.
It's a fundamental shift in how organizations are starting to evaluate AI. For a long time, the narrative was bigger is better, and performance metrics were almost exclusively about raw accuracy or capability. But now, a different metric is gaining traction: the cost per task. And when you look through that lens, the premium for frontier models often doesn't make economic sense.
So the most powerful AI isn't necessarily the most cost-effective AI? That feels counterintuitive for an industry often chasing the next big leap.
Precisely. The data suggests that for a significant percentage of tasks, the incremental performance gain from a frontier model, compared to a slightly less capable but much cheaper alternative, is negligible in practical terms, while the cost difference is substantial. This exposes what some are calling the frontier premium.
Could you break that down? When discussing cost per task, what exactly is being measured, and why is this metric becoming so crucial now?
Historically, when evaluating AI models, the focus was often on benchmarks like GLUE scores, MLLU, or specific task accuracy rates. These are measures of raw capability. Cost per task, however, introduces an economic dimension. It's essentially calculating the total expenditure required for an AI model to successfully complete a single unit of work.
So it's not just about how well it performs, but how efficiently it performs relative to its price tag.
Exactly. Think of it like this. If you're building a house, you don't just look for the most powerful excavator on the market. You consider the size of the job, the type of soil, the time frame, and critically, the rental cost per hour or per cubic yard moved. For AI, the cost per task incorporates factors like API call charges, computational resources consumed, CPU, GPU, memory, and even the hidden costs of integrating and managing that specific model within an existing infrastructure.
That makes sense. It's a practical bottom-line approach. So, a model might have a 98% accuracy rate versus another at 95%, but if the 95% model costs 10 times less per inference, the economic calculation shifts dramatically.
It absolutely does. The performance gap between, say, a top-tier frontier model and a slightly smaller, optimized model for a specific task might be a mere few percentage points, but the cost differential could be orders of magnitude. For an enterprise processing millions of requests daily, that tiny performance delta often doesn't justify the immense additional expense. The economic impact quickly outweighs the marginal gain in raw capability.
It's like asking if you really need a supercomputer to run a spreadsheet.
A very apt analogy. For many routine, high-volume operational tasks, the computational overkill of a frontier model becomes a significant financial drain, not an asset. This shift also implicitly considers the reliability and consistency of the output. If a cheaper model consistently delivers 95% accuracy for a specific classification task, and that's sufficient for the business requirement, then pursuing the extra 3% accuracy from a more expensive model might only be justifiable if the cost of an error is exceptionally high.
You mentioned the frontier premium. What drives this higher cost for the most advanced models, and is it a reflection of their true value or something else?
The frontier premium is multifaceted. First, there's the sheer R&D investment. Developing these leading-edge models requires vast sums for researchers, specialized hardware, and massive datasets for training. This foundational cost has to be recouped. Second, the infrastructure required to run and serve these models at scale is incredibly expensive. We're talking about vast clusters of highly specialized GPUs, sophisticated cooling systems, and constant maintenance.
So it's not just the development, but the operational cost of keeping these behemoths running.
Precisely. And often, these models are designed to be generalists, capable of tackling a huge array of tasks. That generality comes with a computational overhead. A model designed to answer complex philosophical questions might also be used to summarize an email, but it's not optimized for that simple task. It's like using a Swiss Army knife to tighten a single screw when a simple screwdriver would do. The capability is there, but the efficiency for the specific task is low.
So a significant part of that premium is paying for capabilities you might not even be utilizing for a given task.
Often, yes. The market also plays a role. There's a prestige associated with being at the frontier, and early adopters, or those needing to push the absolute boundaries, are willing to pay for that. It's a bit like buying a cutting-edge supercar. You're paying for peak engineering and performance, even if you're mostly driving it to the grocery store. For many businesses, the perception of having the best can sometimes overshadow a rigorous cost-benefit analysis for each specific application.
It suggests a reevaluation is overdue for many organizations currently deploying AI.
Absolutely. The frontier premium isn't necessarily unfair. It reflects the investment and unique capabilities of those models. But the question is whether that premium translates into commensurate value for every task a business throws at it. For many, the answer is increasingly becoming no, driving them to explore alternatives.
Considering that, what about the idea of good enough AI? If the frontier models are too expensive for many tasks, what are the alternatives and how are they proving their worth?
The market is seeing a surge in what could be called fit-for-purpose or good-enough AI models. These are typically smaller, more specialized, or open-source models that have been fine-tuned for specific applications. They might not achieve the absolute peak performance of a frontier model, but their performance is more than adequate for the intended use case.
So instead of a generalist supermodel, is the trend moving towards highly optimized specialists?
Exactly. Consider a task like customer service ticket classification. A highly specialized model trained on a company's specific customer interactions and product vocabulary can achieve very high accuracy for that narrow domain. This model is much smaller, requires less compute to run, and consequently costs significantly less per inference than a general-purpose LLM trying to classify tickets alongside writing poetry or generating code.
And the performance difference in that specific context might be negligible or even better due to specialization.
Potentially better because of that specialization. It's a classic engineering trade-off, generality versus optimization. When you optimize for a narrow task, you can often achieve very high performance with fewer parameters, less data, and less computational power. This directly translates to lower operational costs. This is being observed across various applications, from sentiment analysis to document summarization for specific industries, or even simpler code autocompletion functions within IDEs.
This sounds like a maturation of the AI industry, moving beyond just chasing the biggest model to focusing on practical, deployable solutions.
It's definitely a sign of maturation. The initial phase of AI was often about demonstrating what was possible. Now, the focus is increasingly on what is economically viable and operationally efficient. This shift democratizes access to AI, making it available to a wider array of businesses and use cases that couldn't justify the frontier premium. The barrier to entry for utilizing advanced AI capabilities is significantly lowered when you don't always need the Rolls-Royce of models.
So, if cost per task is the new lens, how does this change the strategic decisions developers and businesses are making about AI adoption and deployment? What's the new calculus?
The strategic implication is profound. It forces organizations to move beyond a simplistic, always use the best available model mentality. Instead, they must conduct a rigorous cost-benefit analysis for each specific AI task. This means breaking down their AI needs into discrete functions and then evaluating which model, or combination of models, provides the optimal balance of performance and cost for that specific function.
So, a single application might now use a patchwork of different AI models.
Precisely. Imagine an application that needs to do several things: generate marketing copy, summarize internal reports, and classify incoming customer feedback. It's becoming increasingly common to see different models deployed for each of these subtasks. A frontier model might be used for the creative marketing copy generation, where nuance and high-quality output are paramount. A fine-tuned, cheaper model might handle internal report summarization, and an even simpler, highly specialized model could classify customer feedback.
That's a shift from a monolithic AI strategy to a more modular, component-based approach.
Absolutely. It encourages a right tool for the right job philosophy. Developers are now looking at an increasingly diverse ecosystem of models, from major providers offering frontier models to open source alternatives to highly specialized niche models, and making selections based on a detailed understanding of the task's requirements and budget constraints. This requires more sophisticated decision-making processes, often involving benchmarking across multiple models for specific use cases.
It also implies that organizations need a clearer understanding of their own data and specific problems, rather than just throwing a general-purpose AI at everything.
That's a critical point. To effectively implement a cost-per-task strategy, an organization needs to deeply understand its own data, the specific outputs it requires, and the acceptable error tolerance for each task. Without that clarity, it's difficult to identify where a cheaper, specialized model will suffice versus where the premium of a frontier model is genuinely warranted. This also means investing in robust internal evaluation frameworks.
This focus on cheap AI and cost per task has significant implications for broader AI adoption. How might it accelerate the democratization of AI, making it accessible to a wider range of organizations?
It significantly aids democratization. One of the primary barriers to AI adoption, particularly for small and medium-sized enterprises or startups, has been the prohibitive cost associated with accessing and running powerful models. If the cost per task for many useful applications drops significantly, it opens the floodgates.
So, businesses with smaller budgets can now afford to integrate AI into their operations, not just the tech giants.
Exactly. Think of a small e-commerce business. They might not be able to justify the expense of a top-tier LLM for dynamic product descriptions or customer support automation. But if there's a specialized, cost-effective model that can perform those functions reliably for a fraction of the cost, suddenly AI becomes an attainable competitive advantage. This could lead to a proliferation of AI-powered services and products across industries that previously felt AI was out of reach.
It essentially lowers the entry barrier, not just for using AI, but for building new products and services on top of it.
That's a key point. It fosters innovation by reducing the capital expenditure required to experiment and deploy AI. Developers can prototype ideas with cheaper models, validate their use cases, and then scale up or swap models as their needs evolve, without being locked into an exorbitant initial investment. This also encourages a more diverse ecosystem of AI providers, as there's a growing market for these cost-optimized, specialized solutions.
This suggests that the landscape of AI providers might diversify beyond the current handful of frontier model developers.
Absolutely. More open-source models are already gaining traction, and new companies are emerging that focus on highly efficient, domain-specific AI. The market is maturing to support a wider spectrum of needs, from the bleeding-edge research labs to the pragmatic business looking for an affordable solution to automate a specific process.
While the case for cheap AI and cost per task is compelling, it can't be entirely straightforward. Are there hidden complexities or challenges that organizations need to be mindful of when pursuing this strategy?
There are definitely nuances to consider. One major factor is the hidden costs that might not appear in the per-inference price. For instance, integrating and managing a diverse portfolio of specialized models can introduce architectural complexity. Each model might have different APIs, different data format requirements, and different deployment environments. This can increase engineering overhead.
So while the model itself is cheaper, the effort to make it all work together might negate some of those savings.
Potentially, it requires a sophisticated MLOps strategy. Another challenge is the task definition itself. What constitutes a task, and how do you accurately benchmark different models across varying levels of complexity? A simple summarization is one thing, but a summarization that requires deep contextual understanding and synthesis of multiple documents might push a cheaper model beyond its capabilities, leading to higher human review costs or quality issues down the line.
So defining the scope and complexity of the task is crucial to avoid false economy.
Exactly. Organizations need to be very clear about their performance thresholds and error tolerance. If a cheaper model has a higher error rate, the cost of correcting those errors or the business impact of incorrect outputs needs to be factored into the cost per task equation. This is where the initial cost savings can quickly erode.
And what about future-proofing or scalability? Are cheaper, specialized models as adaptable as frontier models?
That's another excellent question. Frontier models, by virtue of their generalist nature, often offer more flexibility to adapt to new, unforeseen tasks or to be fine-tuned for a broader range of applications. A highly specialized, smaller model might be incredibly efficient for its specific purpose today, but if business requirements shift significantly tomorrow, it might need to be completely replaced or retrained, which could incur unexpected costs. So the long-term strategic value needs to be considered alongside the immediate cost per task. It's not a binary choice, but a spectrum of trade-offs.
This discussion offers a new perspective on AI value. For listeners, what are the most important takeaways from this shift towards cost per task and cheap AI?
First, the absolute performance of an AI model is no longer the sole or even primary determinant of its value. Its economic efficiency, measured as cost per task, is equally, if not more, important for practical business applications.
Second, the frontier premium exists for a reason: high R&D and infrastructure costs, but it often doesn't translate to commensurate value for every application, leading to overspending on capabilities that aren't fully utilized.
Third, the rise of good enough or specialized AI models offers a compelling alternative. These models, while potentially less powerful overall, can deliver sufficient performance for specific tasks at a significantly lower cost, opening up AI to a broader market.
And finally, making smart AI deployment decisions now requires a deep understanding of each specific task's requirements, clear performance thresholds, and a rigorous cost-benefit analysis that extends beyond just the initial model price.
It means moving away from a one-size-fits-all approach to AI and embracing a more modular, economically driven strategy.
So the question for every organization deploying AI isn't just what's the best model, but increasingly what's the most cost-effective model for this specific task.
And are organizations paying for capabilities they don't truly need? That's the core economic question facing AI adopters today.
That's all for this episode of Context Window. Join us next time for more on the AI tools shaping how we build software. If you're building with AI, subscribe. We cover what matters.
Ship smarter, not harder.